this video, I'm going to go ahead and go through your inequalities or your graphing inequality study guide. Let me go ahead and add graphing because we're graphing two variable linear inequalities. So I'm going to go through this with you. I'll do some and leave some for you to try. We'll take our first quiz on this. I want to shoot for tomorrow. I'll check base with you to see if you understand what's going on, and then we'll take our quiz tomorrow. All right, so let's go start from the beginning. So number one asks, when would the boundary line of the graph of a linear inequality be dashed? And the second, and it also says when would it be solid? So on your paper, you can tell that we have two different types here. One, the boundary line is the line, obviously, that splits the coordinate plane into two. So what happens when it's dashed? A dashed boundary line represents greater than or less than or greater than, while a solid one represents that we use the inequality less than equal to, greater than equal to. So with a dashed, or with a solid example, everything on this side is a solution to the inequality, also including any point on the line, okay? But when you have a dash situation, yes, every point combination over here is a solution, but anything on this dash line does not count as a solution. So the dash line does not include points on the line, while solid ones do. Okay, 2. How do you know whether to shade above or below the line when graphing the inequality on a coordinate plane? Most times it's pretty obvious, but if not, we can always test a point. So we pick a point, a coordinate pair, we plug it into the inequality, and then we check to see if that point is a solution or not. If it is a solution, it must be on the shaded side of the graph. If it's not a solution, it must be on the opposite side, the empty side of the graph. Okay, so let's start with number 3. I'll do number 3, and then I want you to try number 4. So the goal here is we're given the graph of an inequality, and we want to write the inequality. So first things first, I need to write the equation for my boundary line. So it's easiest to use y equals mx plus b, where m is the slope and b is the y-intercept. So looking here, I can't really tell what my y-intercept is, right? All I know is I can easily read the point 1, 5, and I pick the point, negative 1, 5. And the point 1, 2. So I'm going to go ahead and use those 2 points to find the slope. So I'll do 2 minus 5 divided by 1 minus negative 1, which gives me a negative 3 over 2. So my slope is negative 2/3. Now I'm going to use that slope and the equation y equals mx plus b to find the y-intercept and then write the equation of my line. So what I'm going to do is plug in a y coordinate. I'll plug in the m that I found. And then I'm going to plug in my x coordinate of negative 1 plus b. So you see that I didn't steal, but I used the x and y coordinates from one of the points I was given. So I get 5 equals 3/2 plus b. I'm going to subtract 3/2 from both sides. And that leaves me with 7/2. So b equals 7/2, which is 3.5. So my equation would be y equals negative 3/2 x plus 7/2. Now that's the boundary line. The second step is we don't want a boundary line, we want an inequality. So I'm going to pick 0, 0, an easy point to plug in, and see which inequality sign would make 0, 0 not a solution. I know 0, 0 is not a solution because it's not on the shaded side. So if I do y, I'm going to leave a space, negative 3/2 x plus 7/2. And I'm going to plug in 0 for x and y. I get 0 and 7/2. I know that this inequality sign has to be or equal to, right? Because my line is solid. So which one of these signs makes this true? This one does. So my inequality is y is less than or equal to negative 3/2 x plus 7/2. All right, so here's the second one. I want you to try that one on your own. Pick 2 points that you could easily read. I saw the point 0, -4, and 2, 0. So you can go ahead and use those 2 points to write the boundary line, the equation, and then you're going to test a point. I always pick 0, 0 to see which inequality sign you should use. All right, I'm going to skip on down to number 5. So this time we're given the inequality. Y is less than x minus 3. And we want to graph the inequality. So first things first, I need to go ahead and determine my boundary line, which is taking that inequality sign, turn it to an equal sign, and I'm going to graph this. So graph the boundary line. Since it's less than, I know that I'm going to use a dashed line. So my y-intercept is -3. And I have a slope of 1. So I'm going to go up 1 over 1, up 1 to the right 1. And I'm going to go ahead and connect these with a dashed line. Okay? That's your first step. Second step is to go ahead and test a point so we can figure out which side to graph. You're going to test it into the original given inequality. I'm going to test the point 0, 0 because it's the easiest to plug in. So when I plug in 0, 0, it tells me that 0 is less than -3. I know that that is not true. Therefore, 0, 0 is not a solution, which means I don't want to shade the side with 0, 0. I'm going to shade the side without it. So that would be my inequality. I want you to try number 6. I'll do number 7. Y is less than or equal to -2/7 x minus 2. So my y-intercept is -2. My slope is -2/7. So I'll start at -2. I'll go down 2 and to the right 7. That gives me 2 points. I can use my slope to go backwards too, so that I get 3 points. Since it's less than or equal to, I know that it's going to be a solid line. Okay, and then my last step is I need to pick a point so I can throw some shade. So I'm going to pick 0, 0. So y is less than or equal to -2/7 times 0 minus 2. I'm going to plug in 0 for both sides, and I got 0 is less than or equal to -2, which is not true. So 0, 0 is not a solution. That means my line will be shaded at the bottom. All right. Cool. All right, that's number 7. I'll do number 9. Number 9, we just want to figure out if the point is a solution or not. So I'll just do a few of these, but it's just a matter of plugging it in, right? So for number 9, 3x minus 2y is less than 12. And I want to test the point 1, 3. So I'll plug in 1 for x, 3 for y, and I want to see if it's less than 12. So that would be 3 minus 6 is less than 12. So obviously we get -3 less than 12. So yes, this is a solution. So you want to test that until you find one that is not a solution. Make sense? As I go through this also, if you have any questions, write it down. We'll cover it tomorrow. All right, let's do number 11 together. This one should remind you a lot of the pet sitters problem that we did. Carlos has at most $20 to spend on a bouquet of flowers. Carnations cost $1 each and roses $2 each. Let me check my time. Okay, so actually, let's have you guys give this a try. So I want you to do your first step. I want you to write the inequality. So I'll help you out with this first part. So he wants to buy carnations and roses, but he only has $20. So that means whatever he gets has to be less than or equal to $20. So let's let X stand for carnations, Y for roses. Carnations are $1, roses are $2. So that's your inequality. I want you to go ahead and graph this inequality. So start by graphing the line. 1x plus 2y equals 20. You can either leave it like this, or you could change it to slope-intercept form. Since this is standard form, I'm going to go ahead and leave it like this, and I'm going to find my x and y intercepts. So I'm going to find 2 points that are easy to find. So for my first one, I'm going to plug in 0 for x. So I'll get 2y equals 20. That means y has to be 10. And for my second point, I'll plug in 0 for y. So I'll get 1x equals 20. So x must be 20. So using those 2 points, I can plot those 2 points, graph my line. Go ahead, test the point, tell me what you come up with.